Hello students. So in our last class we have discussed about the charges and their properties. Now in this class we are going to discuss about the Coulomb's law. Okay. So our topic is Coulomb's law. Okay. So students, Coulomb's law talks about the interaction between charges. Okay. Let's suppose we have two charge particles. First one is Q1 and second one is Q2. Okay, and let's say both of these two charges are separated by a distance r. Okay, we have two charges q1 q2 and both of these two are separated by a distance r, let's suppose. Okay, so according to Coulomb, the electrostatic force, okay, electrostatic means this charge should be at rest. Okay, this law is only applicable when these two charges are at rest. Okay, if let's suppose this charge is at rest and this is moving, then also this law is applicable. One charge at least should be at rest. Okay, so according to Coulomb's law, the interaction, okay, or you can say the electrostatic force, let's suppose this is F, this force is directly proportional to the multiplication, or you can say product of these two charges q1 q2, and let's suppose this is our equation 1, and this force is inversely proportional to the square of separation between them. What is Coulomb's law? Again I am repeating. So according to Coulomb's, the electrostatic force between two charges, which is q1 and q2, is directly proportional to the multiplication of these two charges and inversely proportional to the square of separation between them. This is the Coulomb's law. Okay, so let's suppose this is our equation second. So combine equation first and second. So when we combine equation first and second, so it will become F is directly proportional to q1 q2 by r square. Correct? And we know that when we remove proportionality sign, there will be a constant. So F is equals to K q1 q2 by r square. What is this K? This is our force. What is this K? K is what? K is constant. K is a constant, or you can say proportionality constant. And this K is medium dependent. Okay, the value of this K is medium dependent. For air, okay, air or vacuum. For air and vacuum, the value of this K is what? It's 9 into 10 to the power 9 Newton into meter square per Coulomb square. Okay, you have to remember this value. For air, the value of this K is 9 into 10 to the power 9 Newton into meter square per Coulomb square. Okay, this is the Coulomb's law. Okay, so Coulomb, we know that force is a vector quantity and it has a direction. So what will be the direction of this force? So direction of this force is, let's suppose this q1 is positive and this q2 is also positive. Okay, so this q1 tries to repel this q2 in this direction away from this, and similarly this q2 tries to repel this q1 in this direction. So this will be the direction of this force. So the direction of this force is along the line joining of center of charge. Okay, along the line joining of center of these two charges. Okay, so here I am writing direction of this force is along the line joining. Okay, line joining center of two charge. Okay, this is the direction of this force. Correct? So now, okay, and this K is constant. This K has a value. Okay, in another term you can say K is equals to 1 upon 4 pi epsilon naught. Okay, this is for air and this we are calling This is 9 into 10 to the power 9 Newton into meter square per Coulomb square. Correct. What is this epsilon naught? This is epsilon naught. Okay. This epsilon naught is known as permittivity of free space. Okay. Free space, or you can say permittivity of free space or air or vacuum, you can say. Okay. And its value is, in air, its value is 8.854 into 10 to the power minus 12 Coulomb square Newton meter square. Okay, Coulomb square per Newton into meter square. This is the value of this epsilon. Okay. So this is the Coulomb's law. Again, I am repeating what is Coulomb's law. So according to Coulomb, the force between two charges is directly proportional to the product of these two charges and inversely proportional to the square of separation between them. Okay. So this K is a constant, and which is known as proportionality constant, and it is medium dependent. This K is what? This K is medium dependent. Medium dependent. This K is medium dependent, and the direction of this Coulomb force is what? Along the line joining of center of two charges. Let's suppose if this is x direction, then I can say this direction of force applied by this Q1 on this Q2 will be along this x cap direction, and the direction of force applied by this Q2 on this Q1 will be minus x cap direction. Correct? So this is the direction of this force. Okay. Now let's solve some questions. Okay, let's have some problems. So my first question is, let's suppose we have two charged particles. First one is Q and second one is Q2. Okay, Q1 and Q2, and both of these two charges are separated by a distance of 1 meter. Okay, so it is the question is, find the electrostatic force between these two charges. Okay, find Coulombic force. Okay, Fc between Q1 and Q1 and Q2. Okay, Q1 and Q2. This is the question. Now, so what will be the force? Force is what? Force is K Q1 Q2 by R square. K, what is Q1? Q1 is Q1, capital Q1. Q2, R square. What is R square? R square is 1 meter. Okay, 1 meter square. This is, let's suppose our equation 2, 1. Okay. Now, let's suppose I am saying if the separation of this charge, these two charges, is increased by 1 meter. Okay. Now, the question is, if the separation of this Q1 and Q2 is increased by 2 meter, increased to 2 meter. Now, this is Q2 and Q1. So, what will be the ratio of forces in this condition and this condition? Let's suppose this is my force F1 and this, let's suppose this is my force F2. So, F2 will be what? K Q1 Q2 by R square. What is R square? 2 meter square. That means it will be what? K Q1 Q2 by 4. And what is the value of F1? This is F2. F1 is K Q1 Q2. So can I put here F1 by 4? So F1 by F2 will be what? F1 by F2 will be 4:1. Okay. That means when we increase the separation between two charges, the force decreases. Okay. When we increase 2 times the separation, force will decrease to 4 times. Correct? So this is called inverse square law. As we increase the separation, the force will decreases as square of separation between them. Okay, let's suppose this is what? This is a inverse square law. What is inverse square law? Inverse square law. What is inverse square law? Force is inversely proportional to the square of separation. When we plot force versus R. Okay, when we plot force versus R, so the graph will be like this. As distance increases, force decreases. Let's suppose when we have distance 1 meter here and we took now 2 meter. So at 1 meter, this will be the force. At 2 meter, this will be the force. So force is decreasing as we are increasing the distance, or you can say as we are increasing separation of two charges. So this is the inverse square law. Okay, so now let's take another example. Now let's take example second. Let's say this is our example second. Let's say we have a triangle, okay, which is equilateral triangle, okay. We have a equilateral triangle and we have placed a charge Q here and Q here, okay. There are three charges and we have placed all these three charges on the vertices of this equilateral triangle. Let's suppose this is A, B and C. ABC is a triangle which is equilateral and the side of this triangle is A, let's suppose. Okay. So our question is what? Find net force. Which force? Electrostatic force or Coulombic force. Find net force on charge at C. Okay. We have to find net force on charge at C. At this location, we have to find net force. Okay. So the solution will be what? So I'm again redrawing this triangle. So this is my Q, this is also Q, and this is my C, which is also Q. Okay, ABC. So let's suppose this is okay. So ABC. Okay, let's write ABC. So force due to this A charge on this C will be what? Away from this charge. Okay, line joining two charge and away. So it will be, let's suppose this is F1 and in this direction. Force due to this Q at B on C will be what? Along line joining and it will repel. So in this direction. Let's suppose this is F2. What is F1? F1 is what? K Q1 Q2, because we know force between two charges is what? K Q1 Q2 by R square. R is what? Separation. So what is Q1? Q1 is Q, Q2 is also Q. So I can say KQ square by what is separation? The separation is given to A. So it will be A square. Correct? So this is KQ square by A square. Similarly, F2 will be what? K Q1 Q2. K Q1 Q2. Q1 and Q2 are equal, so I can say Q square, and the separation is what? Again A square. So these are two forces and both of these forces are in different direction, okay, and both of these two are vectors and we know the result, we know the formula of resultant vector. So if I say in equilateral triangle all three angles are what? 60 degree. This will also be 60 degree. If this is 60 degree, then this will also be 60. And we know that the resultant force is what? Resultant vector we know. If two vectors, let's suppose this is A vector and this is our B vector. Okay. A and B, and both of these two vectors are set at angle theta. So what will be resultant of this vector? It will be what? A square plus B square plus 2AB cos theta. Correct? This is the resultant. So similarly, this is our A, B cos theta. ठीक है. So I'm solving here. Okay, so it will be, let's suppose our resultant force is F net. Okay, our resultant is F net. So F net will be what? F net will be F1 square plus F2 square. Okay, plus 2 F1 F2 cos theta. Theta is what? This theta is 60 degree. So our theta is 60 degree. What is our F1? What is our F1? F1 is KQ square by A square, and similar this F2 is same. Let's suppose this F1 F2 is equals to F, because F1 and F2 both are equal. So what will be the resultant or net force? It will be what? F1 is what? F. So F square plus F square plus 2FF cos 60 degree. Correct? And we know cos 60 is what? 1 by 2. So this 1 by 2 and 1 2 is what? Get cancelled out. So it will become what? FF 2F square plus this will be what? 1 by 2. So this 2 and 2 get cancelled out. So it will become F square. So F net will be what? F net become root 3 times of F. This is our F net, and which will be what? Root 3 KQ square by A square. This is our F net on this charge C. Correct? This is the question. Now let's take another example of Coulomb's law. Okay, let's take example number 3. Let's suppose we have a square and we have put charge Q, Q, Q and Q here. Okay. So what we have to find is, we have to find, let's suppose this is our A, this is B, this is C, and this is our D. Okay, A, B, C, D. And we have put 4 charges on this location A, B, C, D. Question is same. Find net force on charge at C. We have to find net force on charge at C. Okay, question is same, but in this time we have a square of side length what? Let's suppose side length is A. Correct? So solution will be what? It will be, I'm again drawing this square. Okay, so this is my Q, this is also Q, Q and Q. So force due to this Q on this Q will be what? Along this direction, away from this charge. So let's suppose this is my F1. What will be F1? This is separation A. So F1 will be K Q1 into Q2 by separation square. So K Q square by A square. Same. Now force due to this charge on this charge will be what? Away from this charge. Let's suppose this is our F2. So F2 will be what? K Q1 Q2 by A square. A is what? Again A. So KQ square by A square. Correct? Now we have done this charge, this force, this. Now this is only remaining. Third. Force due to this charge on this charge will be what? This is along this direction. Correct? And making 45-degree angle with theta with this. Also this. And this is, let's suppose, F3. So F3 will be what? K Q1 into Q2 by separation square. What is this separation? What is this length? Value of this length is what? Root 2 times A. Okay. By using Pythagoras, because we know this is A, this is also A. So root over A square plus A square, it will be root 2A. So F3 will be what? K Q square by root 2A whole square, or it will be KQ square by 2A square. So if this is F, so this will also be F. So this will be what? F by 2. Correct? So now we have three charges. Three forces. But we have to find resultant. So this F and F, both of two forces are in equal in magnitude, but both of these two are at 90 degree, and we know that when theta is 90 degree, okay, by using this formula, when theta is 90 degree, this term will 0 and it will be what? Root 2f, correct? Root 2f, which is along in this direction, so this will be root 2f along this direction, making 45 angle theta with both of these two axes, and there will be a force also, which is what? F3. So F net will be what? F net will be root 2f plus F3. Correct? Okay. So what is F3? So F3 will be what? Root 2. What is F? F is KQ square by A square plus what is F3? F3 is KQ square by 2A square. When I common this KQ square by A square, so F net will be what? Here I am writing. F net will be KQ square by A square root 2 plus 1 by 2. This is the net force. Okay, net force on charge at C. Net force on charge at C. This is the net force. Okay guys, thank you. I hope you have learned from this lecture, and thank you.